Hi class, so today we are going over exponent rules and our essential question is what are the rules for exponents? So first we're going to go over product rules, but before we discuss this, we need to understand two definitions. We need to know what a base is and an exponent. The base is the whole number or variable that's given to you, and then the exponent is the little number that you usually see next to the number up top on a calculator, or sometimes you'll see it written as the whole number, like let's say for instance 3, you'd have a caret, and then also the number 3. This also means 3 to the third power. So this is how you would see it written in like a calculator, or when you don't have an exponent symbol handy to you for you to make the little small 3, you can put a caret. So first we're going to go over our product rules, and then we're going to go over our quotient rules. So multiplying exponents with the same base. So that means that the base, the whole number, is the same for both. So the rule for that is that you just add the exponents and your base stays the same. So an example of this would be, for instance, if you had x to the 5th times x to the 3rd. Remember, this is your base and this is your exponent. So then x to the 5th times x to the 3rd is equal to x, and then you take the two exponents and add them together, 5 plus 3, which is just x to the 8th. And then let's do another example. Let's say, for instance, we have 9 to the 2nd times 9 to the 4th. That's equal to 9 to the 2nd plus the 4th, which is equal to 9 to the 6th. Basic. So that's when you're multiplying exponents that have the same number as the base or variable. The next situation that we're going to look at is doing a power to a power. So you'll often see power to a power, and what this means is that you're taking the power of a number that's already being powered. So that sounds confusing, but let me show you. So the rule for this is you multiply the exponents and your base stays the same. So if you were to have x to the 4th power to the 5th power, so that means you're taking the 5th power of x to the 4th. So then that's equal to, you leave the base alone, so it's still x, and then you multiply the two exponents. So 4 times 5, which is equal to x to the 20th. And for another example, we'd have 3 to the 7th to the power to the 2nd. So then it's equal to 3 to 7 times 2, and then that's 3 to the 14th power. Also pretty simple. This one is not an operation, but you do need to know the rule, that zero power rule, which the zero power rule is just any number except 0, raised to the 0 power is equal to 1. So that means if you have like x to the 0 power, that equals 1. If you have 30 to the 0 power, that equals 1. Anything to the to the 0th power is 1. The only time that this does not work is when it's 0 to the 0 power. That is not 1. So then now we've gone over the multiplication rules plus the zero power rule. Now we're going to go over the quotient rules. So these are a little different. We have quotient rules now. So first we have product rules, now we have quotient rules, which quotient is just division. Product is multiplication, quotient is just division. So one of the rules for dividing exponents with same base is similar to the product rule for multiplying with the same base, except instead of adding, you're going to subtract the exponents and your base stays the same. Remember, in all of these, you're dealing with bases that are staying the same. This does not work if the bases are different. So for this situation, let's say, for instance, you have x to the 9th divided by x to the 4th. So one thing that I want you to remember, and I want this to be a little reminder on the side, is that when you are subtracting, you subtract the larger number by the smaller number, and you leave in the space of the larger number. So you'll see what this means in a second. So you have x to the 9th divided by x to the 4th. So this would be, we would look at which number is our larger number. 9 is larger than 4. So we want to do 9 minus 4 rather than 4 minus 9. So 9 minus 4, and the x to the 9th is in the numerator. So that means we are going to keep our final answer in the numerator. So we're going to do 9 minus 4, which equals x to the 5th power. So we're leaving it in the numerator because the 9 was larger. So let's try an example where the larger number is not in the numerator. So we have 8 to the 5th divided by 8 to the 14th. And this is equal to, gotta leave our fraction, because if you realize 14 is larger than 5, and that's our denominator, so we're actually going to do 14 minus 5. So then if we're bringing this 8 to the 5th down, then there's nothing on top, so we just leave it as 1. And then 8 to the 14th minus 5, which is equal to 1 over 8 to the 9th power. So remember, the larger number tells you where your final answer should be, whether that's in the numerator and the denominator under 1. So next we're going to talk about negative exponents. So this is a negative exponent. And with negative exponents, you take the reciprocal, keep the base, and make the exponent positive. So what this means is, say for instance, you're given x, so for example, you're given x to the negative 8 power. you would just find the reciprocal. So you'd do the opposite. So then you put 8 to the 8th down in the denominator, because right now it's in the numerator. We're going to pretend that this is over 1. So we're going to take the reciprocal, which is just to flip it. So reciprocal is just flipped. So then now the 1 is going to be in our numerator, and now we have x to the positive 8. And then let's say, for instance, I gave you a fraction already where you have 1 divided by 3 to the negative 4th power. We're going to do the reciprocal, take the reciprocal. So then instead now we'll have 3 to the 4th, positive 4 now over 1, which is just simplified to 3 to the 4th. And one quick reminder on what a zero pair is, because that's really important. If you had 254 to the 0 power, what would that equal, class? Everybody should have said 1. And if you had negative 5 to the 0 power, what should that equal? Also 1. So these are the rules for exponents. If you have any questions, please ask and leave an email. Any questions that you may have or concerns. Thank you.